Welcome back, everybody.
Thank you.
What did you say? What did you say?
It was you who asked where the
how
Earth came
was the
from,
Earth made?
right? No, he asked.
You,
I didn't
you
ask.
said where did the water come from on that Earth?
Mm-hmm.
Or where did the water come from? I said where did Earth come from?
I didn't say that. See, I told you.
No, you said it too. I swear.
No, I said that one. I'm not sure.
Yeah.
She's saving.
All right.
Graduation picture.
Okay, we did. Correct me if I'm wrong. We did 12, correct?
Yeah.
Okay, so we are on problem number 13. My goal is to try to get through as many as we can. I'm not sure if we're going to get the whole thing done. We'll probably be cutting it a little close. Whatever the case may be, it might be good to have at least a couple problems to go through on Monday. Because remember, I won't see you Thursday, and then I'll only see a couple of you on Friday. And then on Monday of next week is our last exam review day. So I'll have a couple problems to go through on Monday. We'll take our exams Tuesday and Wednesday. Sound good? All right. Let's get to it. Find a point on the line y equals 2x plus 5 that is closest to the origin. All right. So these are those maximization problems, right? The next two are those ones where you're trying to maximize something. Let me get the key out here. Whoa. Squeaky makes squeaker sound over there. All right. So what am I trying to do? I'm trying to minimize distance, right? I'm trying to minimize distance. Minimize distance. Okay, so what is the distance formula? Remember, distance formula is x minus x squared plus y minus y squared, right? Where x's and y's are all two different numbers. X1, I could say this, x minus x1 squared, y minus y1 squared. I'm trying to find the minimum distance. Minimum distance. Okay, well, in this case, I know that my one coordinate that I want to use is the origin. So 0, 0. The other coordinate that I want to use is 2x x, comma, 2x plus 5. Right? Where did I get that 2x plus 5? Well, y is equivalent to 2x plus 5. So x, comma, 2x plus 5. All right, so let's plug it in. What did I do on my key? I plugged in x here and then minus 0 squared plus 2x plus 5 minus 0 squared. So that's going to give me an x squared and then the 2x plus 5 squared. So let's FOIL that out. That's going to give me an x squared and then 4x squared plus, okay, we got outers and inners are both 10x. So 20x plus 25. What's wrong? We good?
When you for the first one,
Yep.
It's y minus y1.
Yeah.
Why'd you do 2x plus 5 minus 0?
Because remember, that was my other y value
Oh.
out of the coordinate.
Oh.
And that came from the equation because if I let x be x, I can let y be 2x plus 5. That makes sense? Yeah. All right, so let's keep going here. Let's simplify this down. That gives me an 5x squared plus 20x plus 25. Okay, so that's distance, right? So d is equivalent to square root of 5x squared plus 20x plus 25. So in other words, d squared is equal to this polynomial, 5x squared plus 20x plus 25. Now, remember that I want to minimize distance. Remember, to try to minimize something is to find the maximum or minimum values.
Are we doing a video?
Yeah, did you use our line?
Oh, I did start it. I did. Oh, man. That just means that weird noise that I just Somebody's going to snip it back, I'm sure. Okay, so yes, I am doing video. Thank you for freaking me out, though. So if I want to try to minimize or maximize anything, I've got to find the derivative at that point, right? So if I want to find the derivative, remember that we did this before. Maximizing or minimizing distance is really minimizing d squared as well, right? So if I find d squared prime, right, that's really going to be equivalent. Minimizing the squared distance is minimizing the regular distance, so it doesn't matter. So 10x plus 20 is the derivative. And I can set that equal to 0 because finding the zeros of the derivative are where the maximum and minimum points could occur. So subtract 20 divided by 10, x is -2. And now all I need to do is find the y value of that coordinate. Remember that the coordinate came from y is equal to 2x plus 5. So plugging that in there, y is equal to 2 times -2 plus 5, -4 plus 5 would give me 1. So that means all said and done, -2 comma 1 would be the closest points to the origin. -2 comma 1 would minimize distance to the origin on y equals 2x plus 5. Questions there? Alrighty, let's do another one of those types. Oh no, I lied. 14 is the graphing one, and then we actually get back to minimizing or maximizing something.
Algebra, you rationalize denominators, right?
Yes.
Okay.
Yes. Number 14. Graph the function given the following guidelines. Be sure to show all work to support your answer. This statement is also on your exam. A pre-made graph is intentionally omitted because I didn't want to sway you in any sort of way. All right, so first thing I got to do is find the domain. A says find the domain. Well, the domain here is pretty easy. The domain is all real numbers because it's polynomial. B, the intercepts. Finding the X intercept here, plugging, well, I got to factor. X to the third plus 2x squared minus 8x equals 0. Factor out the x. X squared plus 2x minus 8 equals 0. So x. And then it looks like factors of -8 that add to get to +2 are plus 4 minus 2. X minus 2. So that means x equals 0, x equals -4, and x equals 2 are my intercepts. Checking here. Yep, 0, -4, and +2. Which makes sense because the y-intercept here, see there's no like c value, no ending value. That means that I could write like a +0 here on the end, which means our y-intercept is 0, 0 as well, right? Which makes sense on this guy here. So we have x-intercepts at 0, 0. Actually, I'm going to say at 0, -4, and 2. And then the y-intercept is at 0. So 0, 0. All right, third step there, finding if there is any sort of symmetry. Remember, to find if there's any sort of symmetry, you find f of -x and see what happens. So in this case, it's going to be negative x to the third plus 2 times -x squared minus 8 times -x. So in this case, this is going to be -x to the third plus 2x squared plus 8. Is there any sort of symmetry? No. No symmetry at all. So we say none. Remember that if it was an even symmetry, it would come out exactly the same. An odd symmetry, I could factor out a full negative. Like if I tried to factor out the negative here, this would give me a positive x to the third minus 2x squared minus 8, which is not the same. That minus 2x squared sitting in the middle throws it off. So no symmetry at all, not even or odd. And now we find the intervals of increase. Oh, sorry. D says find the asymptotes. Well, if it's polynomial, are there any asymptotes? No. The only time that you would have asymptotes, are special cases like if it was like a logarithmic function, you'd have a vertical asymptote. Rational functions are the most common ones with asymptotes. You'd have horizontal, vertical, or slant asymptotes. But for our purposes here, since this is polynomial, there are none. E says intervals of increase and decrease, and this is where we have to start to find the derivative. Let's find f prime of x, which is 3x squared plus 4x minus 8. Man, how simple we find finding the derivative nowadays. Yes?
What we have to do is find asymptotes?
I don't believe there's one on the exam review, so I think you're good. Okay, so 3x squared plus 4x minus 8. I need to find the zeros of that. Right? I need to find the zeros of that to find where the possibilities of maximum and minimum values could occur. And where it switches from increasing to decreasing. So this becomes a 3x squared plus 4x minus 8 equals 0. Now, I don't know about you guys, but I don't want to take the brain power to try to factor this and have it not work. So you guys want to just do the quadratic formula?
Yeah.
Why not?
Sure.
Opposite of b, plus or minus the square root of b squared, 9. Oh, no. 16, excuse me. 16 minus 4ac, all divided by 2a, so 6. Okay, let's go on the inside. We have 16 minus 4 times 3 times negative 8, which gets me 112. Negative 4 plus or minus the square root of 112, all over 6. And good thing we didn't try to factor because the square root of 112 is not a nice one. The only times you would end up having it be factorable is when the square root comes out as a nice rational number. So square root of 112, square root of 112 is 10 point, we'll round it to 6. So negative 4 plus or minus 10.6 all over 6. So let's take the plus. 4 plus 10.6 divided by 6. Oh, that's a negative. Shoot. Negative 4 plus 10.6 divided by 6, which is a 1.1. And then let's do the minus. Negative 4 minus 10.6 divided by 6, which is negative 2.4. So those are my two extreme values. To find where they are maximum or minimum values, I need to find, basically do the increase-decrease test. We got 1.1. Oops, sorry. Got to put them in order, I guess. Negative 2.4. And then 1.1. So let's see what's happening on either part. Let's pick something negative. Let's go negative 3, shall we? And remember, you're running these into f prime to see where it's negative and positive. 3 times negative 3 squared plus 4 times negative 3 minus 8. 7. Positive. I don't care about the fact that it's 7. I care about the fact that it's positive. Isn't 0 in between negative 2.4 and 1.1? So if I plug in 0 here, it's going to give me a negative 8. Negative. If I plug in something bigger than 1.1, I bet it's going to be positive, but let's check to be sure. 3 times 2 squared plus 4 times 2 minus 8. Positive, just as I expected. That right there is going to tell me where it's going increasing to decreasing. So this is increasing from negative infinity to negative 2.4, and as well from 1.1 onward. It's decreasing from negative 2.4 to 1.1. All that for just letter E, right? Letter F says to find the maximum or minimum values, find the extreme values. We've really done all the work for it, so let's just kind of state it in the end. Well, if it's going from, yeah, you can put it in the box there. Where is your study hall?
It's the Spanish room.
Okay, let me write your password. 11. Here you go, sir. All right. Here's the extreme values. Now remember, if it's going from increasing to decreasing, the positive to the negative, if it's increasing to decreasing, that's a maximum value. So there is a maximum at negative 2.4, and we should really find the whole coordinate. And there's a minimum value at 1.1 because it's going from decreasing to increasing. And I'm going to be a little cheater here. And if I plug in 1.1, and remember this goes back to the original function to plug these in. If I plug in 1.1, it's 1.1 comma negative 5.04. If I plug in negative 2.4, it's negative 2.4 comma 16.9. Okay? And again, I went back to the original function to do those.
You put that in the X.
Into the x to the third plus 2x squared minus 8x. All right, so those are my maximum and minimum values, my extreme values. And now I'm going to do intervals of concavity and inflection points. Now for that, remember that I need the double prime. So G, I'm going to use double prime. F double prime of x is 6x plus 4. The zeros of that will tell me where my inflection point is. 6x plus 4 equals 0. So x is equal to negative 4/6, so negative 2/3. I should double check because that's where the possibility of inflection point could be. I should double check to make sure that it goes from negative to positive or positive to negative. So if I run a negative number through that, so like negative 1, because it's less than negative 2/3. Negative 1, 6 times negative 1 is negative 6, plus 2 is negative 2, sorry, plus 4 is negative 2. But doesn't matter, it's negative. If I plug anything above negative 2/3, say 1, 6 plus 4 would be positive 10. So it does go from negative to positive, which means that for my concave down, that's going to be negative infinity to negative 2/3. And for concave up, that's going to be negative 2/3 to infinity, because there's my positive area. Which means that my inflection point does occur at negative 2/3. And again, I would go back to the original. Oh, I didn't even write it in here, so I will go back to the original. Negative 2/3 to the third power plus 2 times negative 2/3 squared minus 8 times negative 2/3. 5.9. The original, yep. All right. We ready to graph? Let's do it. I'm going to put it in. Here's H. Okay. So I know that I need to go, I know I have zeros at negative 4, 0, and 2. So I at least have to go like negative 5 to 5. Put it right here, sure. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Like I know my zeros are here. Negative 4. Oh, come on. Blue, please. 0 and 2. We also know that there are maximum and minimum points. My maximum point is negative 2.4 comma 16.9. All right, so I've got to go, let's go by 5s. 5, 10, 15, 20. 5, 10, 15, negative 20. So that means my maximum value is at negative 2.4 comma 16.9. 5, 10, 15, somewhere around up there. And 1.1 comma negative 5.04. And that makes sense because the inflection point is at negative 2/3, comma 5.9, somewhere around right there. And that gives me my entire graph. Remember that I'm going to need to see the work there, right? But this exam is full calculator, okay? So you can use your calculator to, make sure that you're getting the problem right, but I'll need to see every bit of that work to make sure that you did it using the techniques that you should be using, right? Using the increase-decrease test, using the first, second derivatives to find everything you need to find. Does that make sense? Make sure you put the work there. If you just graph it, even if the graph is right, sorry. It's a lot of work to skip out on. All right, questions about that one? That was a doozy. Another doozy. Not so much a doozy. Just one that requires some mental effort. A farmer with 600 feet of fencing wants to enclose a rectangular area, then divide it into 4 pens. Okay, so I've got this rectangular area. Wow, I made that big. And I'm going to divide it into 4 pens with fencing parallel to one side. So I'm going to choose this side here, and I'm going to make it 4 pens. Okay, split it down the middle, split it down the middle, split it down the middle. There we go. 4 pens total. What is the largest possible area for these 4 pens? Okay, so I know I want to maximize area. So let's kind of define our dimensions here. Let's make this x. Do that. Yep. Let's make this x and this y. And this y is the total distance here to here. So that means in the end, area is going to be just x times y, right? That's what I want to maximize. But what I'm given is the perimeter. Actually, not even the perimeter, excuse me. My amount of fencing. How much fencing am I going to be using up? Well, if these are all x, and this whole thing is y, then my amount of fencing is 1, 2, 3, 4, 5 x's and 2 y's, which I need the total to be 600 feet. Okay, now, because I need to maximize, maximize area, I need to get the y out of there, right? So let me create an equation to solve for y that allows me to plug in. So subtract the 5x, 2y is equal to 600 minus 5x, and then I divide by 2. So y is equal to 300 minus 2.5x. Now I can plug that into my area. Area is x times 300 minus 2.5x. Distribute any x. Area is 300x minus 2.5x squared. And the reason we're doing that is because we have to find maximum area. And to maximize something, you've got to find the derivative of it. So now I'm going to find the derivative of that area equation, which ends up just being 300 minus 5x, and setting that equal to 0. Because the zeros of the derivative are the maximum values of the function. Let's add that 5x over to the other side, make it positive. And then we divide by 5. 60 is equal to x. Which means that y is just going to be, actually, I don't even need to find y. What is the largest possible total area? Largest possible total area, I can just plug it back into this equation. Area is equal to 300 times 6 minus 2.5 times 6 squared. I don't even need to find y. 300 times 6 minus 2.5 times 6 squared. 60. Whoops. Yikes. That was 60. Insert a 0. Insert a 0. Pretend that never happened. Oh, geez, oh, Pete. 300, now we can't pretend it didn't happen. 60 minus 2.5 times 60 squared. Much better. I was going to say, how did I not get 9,000? 9,000 area is 9,000 square feet. Square feet? Feet? Feet. Yes. Questions about that one? All right, those are two big problems there. A particle is moving with the given data. Find the position of the particle. So if I know that the particle has acceleration and I want to get to position, am I going to be using the derivative or the antiderivative? The antiderivative, right. I'm going to be using the antiderivative because if I were to use the derivative, like that's working from position to back to acceleration. Going from acceleration to position, making it more general, is using the antiderivative. So this means 6t squared over 2 plus 2t plus c is velocity. But the nice thing is I give you v of 0. So the velocity is really 3t squared plus 2t plus 5. If I were to give you any other value, like I said v of 1 is 5, then you just plug in 1 and set it equal to 5 and see what their c value would be. Okay, and now I do that same thing for acceleration. Or not, excuse me, acceleration, position. So I know s of t is going to be equal to 3t to the third over 3 plus 2t squared over 2 plus 5t plus a new c value, new constant value. But I know that constant value. It's 4. If I were to plug in 0 as my time, set it equal to 4, c would be 4. So s of t would be t to the third plus t squared plus 5t plus 4. All right, let's evaluate the integral for number 17. 2x plus 4 dx from negative 3 to 5. Okay, a definite integral here, right? A definite integral. I can just find the antiderivative and then plug in. All right, so we have a 2x squared over 2 plus 4x. Do I need the c value on the definite integral? No. I can go from 5 to negative 3. And remember, it's always top minus bottom. Let's reduce that really quick. So that's an x squared plus 4x, negative 3 to 5. Top minus bottom. We've got 5 squared plus 4 times 5 minus the entirety of negative 3 squared plus 4 times negative 3. All right, 5 squared plus 4 times 5. That's 25 plus 20. So 45 minus, and that would be 9 minus 12, so negative 3. So 45 plus 3 is 48. $18 looks like a pretty simple one. Remember, for 18, I'm giving you 3 statements here, right? Really 2 statements, and then I want you to find something else. I said if negative 1 to 4 of fx dx is 3.9, and negative 1 to 10 of fx dx is 10.65, then find 4 to 10. And now remember, for these, you can kind of chain them together. You can say, well, if I know, I know that negative 1 to 10 is the sum of anything that breaks in the middle. like negative 1 to 10 is equivalent to negative 1 to 4 plus 4 to 10. Right? I feel like I'm teaching freshmen. Max has no idea. That's just me. And so negative 1 to 10 is 10.65. Negative 1 to 4 is 3.9. And I want to know 4 to 10. Such mature adults back there. We subtract the 3.9. 10.65 minus 3.9 gets me 6.75. That's equivalent of the 4 to 10. We'll make this be our last one. Sound good?
Sir, that sounds very good.
All right. Use FTC1 to find the derivative of the function. So remember, what do we do here? We take this value. When I find d over dx of this, I'm going to take this value and plug it right in there. Right? So this is going to be 3 over 2x squared minus 1 minus 5. And then remember that if I'm finding the derivative of this, I'm peeling back a layer of the integral, and now I have to multiply by the derivative of the piece that I plugged in. So I'm going to multiply by 4x. So all said and done, that gives me a 12x over 2x squared minus 6. And I can divide that all by 2. So 6x over x minus 3. Oops, sorry. That should be a squared down there. All right, so for Monday, we'll finish 20 to 20. How many questions on this? 24, 25? 25. We'll do 20 to 25 on Monday. All righty. So long, everybody watching along at home.